Okay, welcome to this very short video on a rather interesting little problem. This is an algebraic fraction and we are asked to simplify it, but I'm just going to change the question slightly and tell you that this is actually equal to 3. Okay, now you might be thinking, how can that be? Well, we're going to work it through and show that in fact that algebraic fraction, regardless of the values of a and b, is equal to the number 3. So how do we do it? Well, here we go. Look at the top line. We have 2 brackets. Each one is squared. So we're going to multiply out the brackets. So here we go. 2a minus b times itself. I'm going to write it out as a pair of brackets side by side. Okay, 2a minus b. And from that, I'm going to take away the product of a minus 2b times itself. Okay, a minus 2b. And all of that is going to be over a common denominator of b squared, a squared minus b squared rather. Okay, now you may recognize the denominator as the difference of 2 squares, because that's actually a minus b times a plus b. But for the moment, I'm going to leave it just as it is, okay, because I may not need to do anything with it, as you might see in a moment. By the way, if you want to proceed and have a go at completing this, please do, and then pause the video and play it back afterwards. But I'm going to carry on with it now, and I'm going to work on this. So 2a times 2a is 4a squared. Okay. So I'm doing first, then I'm doing outer, then I'm doing inner, then I'm doing last. So the outer is 2a times minus b, which is minus 2ab, and the inner is also minus 2ab. So it's minus 4ab altogether, combining the outer and inner terms. And the last term is plus b squared, because it's minus b times minus b. So it's plus b squared. Okay, so that part there represents the first product of these 2 brackets here. I'm going to put them in another bracket. I don't actually need to do that, but it's just helping to show separate out the different steps. Now I'm going to work on this bracket in the same sort of way. So I've got a times a, which is a squared. Okay, so I've got a squared, and then I've got my outer term, which is minus 2ba, and my inner term, which is minus 2ba. So altogether that's minus 4ba, or minus 4ab. Okay, and my last term is going to be minus 2b times minus 2b, which is plus 4b squared. Okay, and all of that has the same denominator as before, which is a squared minus b squared. Okay, now it still looks nothing like the number 3, but it will do in a minute. So what have we got? Well, remember when we have a minus sign in front of a bracket, every term inside that bracket, you've got to think of doing the opposite with the sign. So I've got a 4a squared minus an a squared, which is 3a squared. That's simple enough. Okay. I now have a minus 4ab minus minus 4ab, and the minus minus is like plus, so that's like minus 4ab plus 4ab, which is 0. And I've got a b squared minus a 4b squared, you see, which is negative 3b squared, or minus 3b squared. And on the denominator, I still have my a squared minus b squared. Okay, now we may already be able to see that we're nearly there, because you now have a common factor of a squared minus b squared on the top and bottom. So I can rewrite the numerator of this as 3 lots of a squared minus b squared. Okay, and the denominator is just a squared minus b squared. All right, now because the numerator and denominator contain a common factor of a squared minus b squared, I could just cancel them out. And if I do that, a squared minus b squared divided by a squared minus b squared is 1. And lo and behold, I'm simply left with the number 3. So the answer is in fact 3 as required. We often say that at the end of a proof, equals 3 as required, because we were asked to show that it was equal to 3. So what that actually means is that if you choose a number for A and a number for B, and you use the same value of A throughout and the same value of B throughout, it will give you the answer 3. Okay, so it's an interesting little result, because when you first look at that and someone tells you it's equal to 3, you can't see why. There's no reason why you would assume that, and you might be thinking, well, it depends what A and B are, but in fact it doesn't, as we've just shown here. Okay, so an interesting little problem using algebraic fractions and the use of a negative sign in front of brackets, which you've just got to be really careful when you're doing that. Okay, hope that was interesting and helpful. Take care.